Hello, my name is James Brown, and I am going to be going over my monitoring tool, my file monitoring tool, and I call it Sniffer Log. What this program does, it starts monitoring a specific folder. When a file or folder is created, deleted, renamed, or modified, it is going to log that event, and it is also going to send you a real-time notification on your desktop or the device that you're using. I have debouncing so that it doesn't send duplicate notifications. And most temporary files for the purpose of this demonstration are set to be ignored. That way we don't have unwanted notifications while we're demonstrating this. There are some temporary files that do not need to be included because it's just files that the computer adds as a temporary file and deletes right away. So some of those, for the purpose of this demonstration, we're not going to include. Right? So in short, this program is going to monitor any activity in a specific file or folder, and it'll send you real-time alerts, and which this is very helpful in the cybersecurity world, where as if someone is trying to remotely access your device, or if they're trying to change documents or things that you may have in folders, it will go ahead and send you a real-time notification. That way, it's not something that you have to wait to find out about later. You can find out immediately and try to stop it. So that's the overview of what my program does. It's a working forensic tool. It's written in Python. It automates monitoring and logging of file system events. It increases efficiency by integrating real-time notifications. It logs forensic relevant data. So it has event types, file paths, and timestamps that it logs. This is an open source and published program that I have on GitHub, and it includes documentation explaining its use and forensic relevance. First, I want to go into the code and explain some of the code that I have here. We have the import and libraries that we have that we're going to be using. OS provides functions for interacting with operating systems like handling file paths. Time is used for real-time related functions like adding delays and timestamps. We have threading, which is allows notifications to run in parallel without freezing the main program. We don't want to crash that, so that's what threading is going to help with. We have our logging, which is going to log files and folder changes to a log file for a later analysis. We have our watchdog observers and import observer, and this is going to continuously monitor a directory and detect changes. So it'll monitor the file creation, deletion, updates. We have our watchdog events, and import for file system event handler. And this is a customizable event handler for file system changes. And we have, I'm not sure if I'm saying that right, WinOtifi notifications. And this sends the desktop notifications for events, file modified, deleted, updated, things like that. So this is what's actually going to send the push alerts to our device, right? Or to our desktop. So to start, we're setting up our logging. So we have a log file is created at log file path to store activity, such as file modifications, deletions, or renaming. We have level equal logging.info, and that's going to ensure all relevant information is logged. We have the format that adds the timestamps for the log messages for better tracking. We have the debouncing and notifications. So this is tracks the last logged event to avoid spamming notifications for the same activity within a short time. We have our log event, writes a specific event like file deleted or something like that into the log file. We have our send notification, and this creates a desktop notification using the WinOtifi library. And if the notification fails, it also is going to log that error. I thought that was a good idea because sometimes the notifications may fail or maybe there's some type of backdoor where that is disabled, but we are still able to log that event. So that would be helpful um, if we are using cybersecurity tools to monitor things that have happened. So this is how this is used to send the messages. We have our scheduled notification. It ensures that the notifications run without blocking the main program. If the main thread is busy, it runs notifications in a separate thread. We have our we have our debounce notifications, and this prevents duplicate notifications by checking if the event is different. Enough time has passed since the last event cooled down period. So that's what the cooldown period is, and updates the last event directory to keep track of time and the type of event. So we have it set for 10 seconds. That way it doesn't constantly send messages or the same message over and over again. We have our change handler. This is the core functionality. The change handler class customizes what happens when a file system event occurs. We have our event on modified, and this logs and sends notifications for file modifications. It ignores temporary files, like I stated earlier, and logs the file itself. All right. On the event on created, this part, it detects and logs the creation files and folders. That's what this section does. On deleted, it detects and logs the files of folders that were deleted. Moved is similar. It checks if there was a move or like a rename in this pathway. And then we have our temporary files. This is where we have these are some of those files that I stated that we have to ignore. Sometimes the computer, when you're doing different things, it'll add different files like this when creating things. And when I didn't have this part ignored, it just sent nonstop alerts. So I had to ignore some of these temporary files to exclude that um, because of some of those were irrelevant for forensic purposes. All right, here is our main function. So we have the path to monitor, and that is a directory where it's being monitored. We have our observer, and that watches the directory and triggers the change handler events. We have our try and accept, and this is going to start monitoring with the observer.start, and then it stops monitoring cleanly when the user presses the control C. And then we have the end. So this is the program. Now it's set to run in the terminal, so you can run it either through. I'm using VS Code, so I can just press play, and I can run it here through VS Code. I'm going to open up my file that I'm using for this. So let's say that we want to add a new file or new folder. When you create a new folder, you get a pop-up in the right-hand corner, and it shows you that a folder was created, and it shows you the pathway. It shows you the pathway that the folder is created for. Let's say, and then you see how it kind of stays there for a little bit. That way it doesn't send multiple ones. Let's say we want to change this folder. Let's say someone logs in and they try to add a folder, and now they're trying to change that folder name. And then once you change the folder name, you see another pop-up that comes there. Let's say they want to create a folder and they add another folder inside of that folder or a file or something like that. You get a pop-up for that as well. So any activity in any of these folders, um, you will be alerted. Let's say if they open the folder and they're trying to delete folders or files, you get a notification that that file has been deleted. So what this does is it sends you real-time notifications when anything has been updated, created, deleted, changed in any type of way. So again, this can be used to also help detect if someone is trying to remotely access certain things. That was a way that I was going with this, but I ran out a little bit of time. But that is something that can be integrated into the system. And you can also check if someone is remotely accessing any of these files or folders or making any changes. And this is something that can be really helpful in the cybersecurity world. So we have here in the terminal, you can just do Control C and it'll stop it right there. So also, you, I have it set up in this folder. So let's say if I want to, oh, I can also do this on a regular terminal. We just need to go to the folder that we're going to be using. So I already have some shortcuts here that I'm going to use for time's sake, and then I'm going to start that program. To start the program, you just need to write Python and then the actual name of the program. And then once you do that, you can see that the monitoring path, and it shows you the folder that is actually being monitored. So I have my document folder 412. The monitoring has started, and we can press Control C to whenever to stop. And it still does the same purposes. If I want to delete something, it will give me a pop-up right here and show me that a file was deleted. And it shows you the file name that was deleted too. And again, this can be really helpful when you are trying to stop real-time cyber hacks or someone, any threat actors that are real-time trying to obtain any information. We can see that immediately. You don't have to wait. It also shows you some type of an alert. Um, and then another thing that it has here, we have our system monitor log, and it shows you different timestamps of things when a file was deleted, a file was modified, created, modified. So you can also go and review those and see more access. So let's say maybe you missed a alert, but you saw that something was created, then you can just go to the system monitor log and then you can go and you can review all of those. And again, it has the date and the actual time. It has the action that was taken, and then it shows the folders and files that was affected from that activity. Also, if it does fail to send you a notification, it will automatically log that event still. So it's still something that you can go, and this is something that can be very helpful to see what was changed, what was deleted, and any of that information. So that is the gist of my program. Again, it'll monitor a specific folder or pathway. So if I wanted to go and put this on one of my main folders, I could put that on that. I'm a little used up on my space there, so ignore that. It's due to excessive gaming, I guess. Um, but you can put that on the main folder that has a lot of activity, or maybe an important folder that has sensitive activity, and then that way you can help monitor in real time and stop any threat actors from taking any information that is sensitive. All right. Thank you for reviewing my program.